It's huge. It is the biggest scientific problem of the age. Navigators on board ships are unable to calculate their longitude once they have left sight of land. Now, to know where you are on the surface of the planet, you need two coordinates. You need to know your latitude, which is how far north or south of the equator you are. And the equator, it forms a natural 0 degrees for latitude. And we've known about calculating latitude since around 350 BC. Basically, the angle of the sun at noon gives you your latitude. But longitude is an entirely different problem. Longitude is time difference. It's the difference in time between where you start and where you are now. As an example, let's say we sail from Greenwich to New York. Now, when we leave Greenwich, we set our watch to Greenwich time. And we don't change it. We leave it on Greenwich time for the whole voyage. When we get to New York, we take the local time. Let's say it's noon, 12 o'clock. But our Greenwich watch tells us that it's 5 p.m. So there's 5 hours time difference between Greenwich and New York. So we could say that New York is 5 hours longitude west of Greenwich. But that's much too easy. It doesn't sound scientific enough. Let's make it more complicated so no one can understand it. So to make it more complicated, if you think of the world as a circle, and a circle is divided into 360 degrees. The Earth spins once in 24 hours. If you divide 360 by 24, you get 15. So every hour, the Earth spins through 15 degrees of longitude. For us on the surface, it looks as if the sun has moved across the sky by 15 degrees. New York was 5 hours difference. 5 hours times 15 is 75. So New York is 75 degrees longitude west of Greenwich. Easy peasy, no problem really, if you've got a watch. But we're in the 17th century, and nobody has a clock or a watch that will work at sea. There are accurate clocks, but they work with a pendulum, like this one here on the wall. And a pendulum, it works great if the clock is on solid ground. The pendulum will swing back and forth regularly. It keeps good, accurate time. Take it to sea, the motion of the ship sends the pendulum swinging about all over the place. The clock loses time, it's useless. Now, astronomers have started to work out that if you have an accurate map of the heavens, so that you know exactly where a star is supposed to be and when it's supposed to be there, you can, by calculation, work out the time at Greenwich. But there is no accurate star map. So in 1675, King Charles II is persuaded to build this observatory for the express purpose of aiding navigation. It is nothing to do with studying the stars, it's purely to do with navigation. Now, it's going to take the astronomers over 100 years before they come up with an accurate star map. In the meantime, trade is building up between Europe and America, and more ships are being lost. Navigators don't know exactly where the ship is, when they meet land, they don't know whether they're going to hit the rocks or a safe port. The merchants, they're not so worried about the ships. Plenty of wood, build another ship. Couldn't care less about the sailors. Raid another tavern, grab some more sailors. But the goods are worth money. Lots of money. They complain to the British Parliament. Something must be done. We cannot afford to keep losing all our goods. So in 1714, the British Parliament issues the Longitude Act. It offers a reward of £20,000, which is about £6 million in today's money, to anyone who can solve the problem of calculating longitude at sea. A board of longitude is established to test solutions, and with that amount of money, many crackpot ideas are put forward. To win the prize, the solution has to prove accurate to within half a degree of longitude, which is about 30 miles. It has to go to the West Indies to prove itself. It has to be practical. It has to be affordable. Well, there are only really two solutions, two viable solutions. One, continue mapping the heavens. The other, develop a sea clock. Now, many people, including Isaac Newton, do not believe that anyone could develop a sea clock. But in 1730, anyone turns up. His name is John Harrison. He is a carpenter joiner by trade and a self-taught clockmaker. He knocks on the door here at the observatory. Edmund Halley is the astronomer royal at the time. He says to Halley, "I have a design for a sea clock." Halley is excited. He introduces Harrison to George Graham, a well-known clockmaker in the city. Graham is excited. Graham loans Harrison £250 to turn his design into reality. Let's go and look at the reality.